The twinkling of stars is an illusion, an effect created entirely by Earth's atmosphere. Starlight travels trillions of kilometers through the vacuum of space. Upon arrival, it is essentially a single, perfect point of light. However, its journey is not over. To reach our eyes, it must pass through our planet's atmosphere. The atmosphere is not a uniform medium. It is a turbulent ocean of air, composed of countless small pockets or cells of varying temperatures and densities. Each of these cells acts like a small, shifting lens. Job. YouTube. Short. General knowledge explained. Topic. How does our atmosphere make stars twinkle? Thumbnail direction. Visual. A single straight golden ochre line descends from the top center against a deep charcoal background. It strikes a translucent, curved boundary representing the atmosphere. Below this boundary, the single line fractures into a shimmering, slightly chaotic, zigzagging path, visually representing refraction. Text. The illusion of twinkling. Font. Montserrat bold. In a sophisticated, muted off-white for high contrast and readability. Hatcheries. Visual direction. 0 to 5 seconds. Scene. A deep teal, almost black background. At the top, a single sharp point of golden ochre light represents a distant star. A perfectly straight, thin beam of light descends from it. Overlay. Minimalist text appears. Stellar scintillation. 6 to 15 seconds. Scene. As the beam of light continues downward, it enters a stylized representation of the atmosphere, a series of translucent, overlapping layers in slate gray and soft blue. The layers have a very subtle, slow, wave-like motion. Action. The moment the light beam enters the top layer, it begins to bend and refract. The straight line becomes a slightly jagged, shimmering path. Infographic. Abstract, geometric shapes, representing pockets of air, fade in and out within the atmospheric layers. As the light path hits them, small, clean arrows briefly appear, indicating the change in direction. 16 to 24 seconds. Scene. The perspective shifts to a ground view, represented by a simple charcoal-colored horizontal plane. The refracted, shimmering light beam terminates on this plane. Its endpoint flickers and moves slightly, illustrating the perceived change in brightness and position. 25 to 35 seconds. Scene. The frame splits. On the left, the twinkling star. On the right, a new object appears at the top. A small, solid disk of burnt sienna, representing a planet. Action. Multiple parallel beams of light descend from the planetary disk. As they pass through the same turbulent atmospheric layers, each beam refracts individually. Infographic. A simple, elegant overlay on the right side shows these multiple, varied light paths converging and averaging out, resulting in a single, steady, non-flickering point of light on the ground plane. 36 to 45 seconds. Scene. The camera pulls upward, reversing the journey. It moves through the atmospheric layers, and the star's light path becomes progressively straighter. Final shot. The view is now in space, above the stylized curve of the Earth. The star is once again a perfectly steady, unwavering point of golden light against the deep, quiet void. Script. Narration. Stars appear to twinkle due to a phenomenon called stellar scintillation, an optical illusion created entirely by Earth's atmosphere. From our perspective, a star is an extremely distant, single point of light. This pinpoint of light must travel through our planet's turbulent atmosphere, a dynamic medium of shifting air pockets with varying temperatures and densities. Each of these pockets acts like a microscopic lens, bending or refracting the starlight's path in random, rapid succession. This constant, chaotic refraction causes the star's apparent brightness and position to fluctuate, creating the shimmering effect we perceive as twinkling. In contrast, planets do not twinkle. Being much closer, they appear as small disks rather than points. The light from this larger area is less distorted by atmospheric turbulence as the various refractions average out, delivering a steadier image to our eyes. Above the atmosphere, in the vacuum of space, stars shine with a constant, unwavering light. The twinkling is purely a terrestrial artifact. As the single point of starlight passes through these turbulent cells, it is refracted or bent repeatedly and randomly. This is the same principle that causes objects to shimmer when viewed through the hot air rising from a sun-baked road. This constant, rapid bending of the light path causes the star's apparent position and brightness to fluctuate from moment to moment. Our eyes and brain interpret this rapid fluctuation as twinkling. Planets, by contrast, do not typically twinkle. Being much closer, they appear as tiny disks, not single points. Light from across a planet's disk travels through numerous atmospheric paths. The individual refractive distortions from these paths average out, resulting in a steady, constant glow. Therefore, stellar scintillation, the scientific term for twinkling, is not a property of the star itself. It is a direct observation of the dynamic, ever-changing nature of our own atmosphere.